Hello, and welcome to I Know Dino, the Big Dinosaur Podcast, where we cover news, interviews, and discussions of all things dinosaur.
Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today we'll be talking about Muttaburrasaurus, as well as a bunch of dinosaur news. We're still catching up a little bit, so we've got a lot of heavy-duty dinosaur news to report.
I just want to quickly jump in and say thank you to all our Patreon supporters. October was a little bit of a slow month for us since Garrett was recovering from his surgery, but we are slowly getting back on track, as Garrett mentioned, with our dinosaur news, and we're really grateful for all your support. If you are listening and you want to support this podcast, you can find a video of information and perks that we offer and the goals that we're trying to reach on our Patreon page, and that is patreon.com/iknowdino, and Patreon is Patreon.
First in the news, an article published in the journal PLOS ONE titled First Reported Cases of Biomechanically Adaptive Bone Modeling in Non-Avian Dinosaurs, written by George Cubo and some others, including Jack Horner, who we interviewed back in episode 37, where we talked about Maiasaura. It was published a few months ago, but we're covering it now partly because we got an email from listener Max who asked, how do we know when a dinosaur has reached adulthood or full size? And we talked about that a little bit with Jack Horner, and you can also see a lot of details in the TED Talk that Jack Horner does, and he talks about how the bones of adults look different from juveniles, and how sometimes that might lead to misclassification or showing more dinosaur species than there really are, when some might just be juveniles of other, although that is still a little bit contested. The article also has lots of pictures that show the difference between the adult and juvenile bone, so you can look at that for some examples. But back to the story of this article. So they looked at 50 tibia from Maiasaura to investigate how the bones heal, and of the 50 bones, 2 of them had an outgrowth, which is what the paper focuses on. The authors say that the kind of outgrowth that they found on these tibias could be a result of an infection, a trauma, or a disease, but in this case, both of the bones that they looked at appear to be the result of a sort of trauma, but not the kind of trauma you might think of. Specifically, they think that the fibula next to the tibia fractured, and that caused extra strain on the tibia, ultimately causing the tibia to grow some extra bone as a result of that strain. And they think that that's a result of Maiasaura being a transition species from bipedal to quadrupedal. So this wasn't noticed until just now, because many of the bones from the formation are, quote, tectonically distorted or deformed, end quote. So the bulge wasn't recognized as a growth. You can imagine if it was squished or twisted or something, that you might see these kinds of shapes and just figure, that one got squished under a rock when it was forming. But when they sliced out a thin section of the bones, they confirmed that the area in question was in fact a growth, and that it didn't appear to be caused by a fracture, disease, or infection, ultimately leading them to believe that it was caused by the increased strain of the quadrupedal stance. So the authors call it, quote, biomechanically adaptive periosteal bone, and they think it results from the dinosaurs being bipedal when young and then switching to quadrupedal as they got older, which resulted in different strain on the bones, which were ultimately reinforced by these growths. So I think that's pretty fascinating. I hadn't really heard of that kind of growth before, but it makes sense in some of these species where they get so big and then they can't support their weight that it would put interesting stress on their bones, especially being less robust than mammal bones or other modern animals.
In some other news, scientists now think that the theropod Nanotyrannus may actually be a teenage Tyrannosaurus. At the 75th Annual Society of Vertebrate Paleontology Conference in Dallas, Texas, which took place in mid-October, paleontologist Thomas Carr talked about how Tyrannosaurus looked really different throughout its life, based on a skull found in Montana in 1942. The skull was nicknamed the Cleveland skull, as well as another specimen. So the Cleveland skull, Robert Bacher and his colleagues claimed, and this became very controversial, in 1988 that this meant there was a new genus called Nanotyrannus. But the second specimen that Thomas Carr compared is a known juvenile T-Rex that was found in 2001, and this T-Rex is nicknamed Jane. Jane was about 11 years old, a little bit older than the Cleveland skull, but was about to go through a growth spurt and eventually probably look like a typical T-Rex. Jane, at 11 years old, though, has a more narrow skull than a typical T-Rex. So Thomas Carr, along with other researchers, actually previously objected to Nanotyrannus being a distinct genus, and it started back in 1999. He proposed it was actually just a juvenile T-Rex. There are some that still believe Nanotyrannus is its own genus due to other fossils that have been found, but according to one article, quote, "These fossils have not been placed in accredited museums or other public institutions," end quote, and therefore don't meet paleontology standards. So Thomas Carr said his proposal isn't just based on Jane either, but on a sample of younger and older animals as well. Still, not everything's known about a T-Rex's growth stages, and one thing that would help would be to find a specimen that shows when the skull changes from long and narrow like Jane's to the deep jaws that everyone knows T-Rex to look like.
Next in the news, an article pre-printed in the journal Peer J, so it hasn't been peer-reviewed yet, but it's available to be reviewed, I guess. And he also opened it up for comments, which I hadn't really seen much of before, but there are some very interesting comments at the bottom of the article by pretty knowledgeable people. It's titled, "Almost all known sauropod necks are incomplete and distorted." It's by Michael Taylor, and he actually wrote this one by himself, which is a little bit unusual. There are very few complete necks that have been discovered, and some of the most well-known and important specimens have incomplete necks. So the author attributes this to the fact that the large size of a sauropod can't quickly be covered by sediment, which is required in order for fossilization to occur, as it can with a smaller specimen. If you imagine, say, an animal dying near a river and then sediment laying on top of it, if the dinosaur is 50 or 60 feet long, it has to line up just right in order to get covered. And then even still, it's kind of likely that one of the bones might get washed away or something else might happen to it. And then he also points out that many of the vertebrae that we do have are badly distorted because they are relatively lightweight and air-filled for bones. So that all leads up to, while it's in the fossilization process, which has to mean that it's being covered by something, if there's too much weight, then it squishes it and you end up with a vertebrae that doesn't necessarily look that much like it did when the animal was alive. He has an example of it where he tries to stick together two vertebrae and see how they would move together, but they barely even look like they would fit together, even though it was fossilized in a way that you could tell that they were in the spine next to one another. One of them was just so distorted, or maybe both, it's hard to tell, that you couldn't really see how they worked. So why does it matter? A lot of fossils are distorted, and we've discussed many times before that complete specimens can be rare. But without a complete undistorted neck, it's difficult to analyze the nuances of how it held its head, what its posture was, and how it would have used its neck when it was articulating it. So, like, could it bend its neck all the way around like an elephant's trunk to get towards its back, or could it lift it really high or go all the way down to the ground, or what kind of range of motion it has? You have to look at the neck vertebrae interactions, and if they're distorted, it really makes it difficult to see how they fit together. So there's a lot of discussion about this, and it looks like it's true that there are very, very few, or maybe even no, complete undistorted sauropod necks. So I don't really even know how they decide how these things move. I guess, like with most of these dinosaur discoveries, you find a piece here and a piece there, and the similarities you kind of put together from families of dinosaurs, and you make assumptions about which ones are distorted versus other ones, and you look for similarities. But it makes me think that the only way we'll ever really understand what a full-size sauropod looked like, to see how they could bend their necks, would be to find a way to determine what they looked like before they were distorted. So you can look at a skull, say, that's been kind of crushed down. They often get crushed too because they're a little bit hollow from, the opening of the mouth and the brain case and everything. And if you could look at it in a certain way to tell where it was distorted, for instance, if you could look at it on like a cellular level and see the cells that were getting squished in one spot or maybe stretched in another spot, we might be able to figure out what the bone looked like before it was distorted. But I don't really know if that's possible with our modern technology. Hopefully someone figures out a way to do it.
And speaking of sauropods, Diplodocus wasn't the only sauropod whose tail could potentially break the sound barrier. Researchers have made a model of an Apatosaurus tail out of aluminum, stainless steel, neoprene, and Teflon. It's 12 feet or 3.6 meters long, which is only about a quarter the size of an actual Apatosaurus tail. But it's true to scale and can break the sound barrier. This is according to Nathan Myhrvold, the CEO of Intellectual Ventures and leader of the team who made the tail. Nathan and his team showed the model at the Society of Vertebrate Paleontology conference, and though the tail took 9 months to design and build and test, and interestingly it's attached to a camera tripod in lieu of a quote-unquote dinosaur butt, Nathan has been working on sauropod tails for the last 20 years, and he even co-wrote a study with Dr. Philip Curry in 1997 that suggested that Apatosaurus and other sauropods could break the sound barrier with their tails based on a computer model that they made. However, paleontologist Kenneth Carpenter at the time said that he didn't really believe the computer model, and he would be more accepting of this theory if there was a scale model. But he also still has some problems with this new scale model, such as the fact that the tail is currently more flexible than a real sauropod's tail, and there's no skin and muscle that could potentially limit the tail's motion. So there's still some debate on whether or not the tail could actually break the sound barrier, but Nathan and his team plan to keep working on the model to make it more accurate. And luckily nowadays, making these kinds of models is much easier to create than, let's say, 20 years ago, and this is because we can now scan fossils and print 3D replicas.
Since we're on a bit of a sauropod roll here, I might as well throw another one in the mix. There's another article published in the journal PLOS One titled A New Titanosaurian Brain Case from the Cretaceous Lo Hueco locality in Spain sheds light on neuroanatomical evolution within Titanosauria. It was by Fabian Knoll and others, and unlike the other stories that I've mentioned, this time we're talking about a fossil that was only minimally distorted by fossilization, despite being, relatively hollow. So the specimen is called MCCM HUE 1667, and it doesn't have any kind of cute name or anything. It is from the Lo Hueco site in eastern Spain. The site and fossil were discovered in 2007 when working on a high-speed rail project in Spain, and several titanosaurs are known from Europe, but they believe their research shows that this one is a new species, which is why it has that funny name, but they haven't actually named it yet. So my favorite thing about this article is there's an awesome 3D model on sketchfab.com, and we'll put a link up on our blog, that shows how the brain looked, back when it was still alive and walking around. And they based all this by the brain case inside the skull. So I think we've mentioned before that they can do these endocasts of cavities inside a skull and then kind of guess at what the brain would have looked like, because there's lots of texture to that endocast, and then basing it on similar animals and certain things that have to be there. For instance, connecting what's obviously an orbital socket to the brain, there must be an optic nerve there or something, and blood supplies and all that kind of stuff. They can kind of come up with a model of what the brain probably looked like. So it's really cool on this website. When I went there, it popped up right away and you could spin it around and look at different angles of it. And it shows the brain in this big blue blob, and then it's got an artery that's supplying the brain with blood in red, and it's got nerves like the optic nerve in yellow, and then it's got a thing called the labyrinth, which is the inner ear structure, in pink. And the background behind it on this website is actually pictures of the skeleton being excavated. So it's pretty cool just to go there and take a look at it if you don't want to read the whole article, because that's a little bit heavy. And just in case you're wondering, the brain is about 6.3 centimeters or 2.5 inches long, despite it being in this massive titanosaur. The article also shows a comparison between models of their unnamed species and Ampelosaurus, Janosaurus, which are both titanosaurs, as well as Camarasaurus. And, that one's not a titanosaur, but it gives a good comparison. And they attempt to put them into a phylogenetic tree just to see kind of how the brain is related to the evolution. But they stated that, quote, recent phylogenetic analysis of titanosaurians have not included virtually any of the taxa under consideration here, and thus the phylogenetic position of the new Spanish titanosaurian Even its generic, let alone specific identification is not possible at this moment, end quote. So, in other words, it's hard to tell how the brain evolved because we don't really know where they fit in the family tree of dinosaurs. Also, in an interview with the Mirror UK, Dr. Noel from the University of Manchester said, "This is such a rare finding, that is why it's so exciting. Usually we find vertebrae or other bones, very rarely the brain case, and this one is complete. I was present on the dig site when it was uncovered, and it was a very special moment. Currently we know very little about the brain of dinosaurs. We might be able to get an idea about the cognitive skills of these animals, or if they had keen hearing or good eyesight, and plenty of other information from these finds. And in a few years' time, if more finds like this come to light, and above all, if they are studied with the modern imaging technologies, then we could really start to understand more about dinosaur brains." So I think that's pretty fascinating because from brains you can tell whether they use their eyesight more than their hearing, or what kind of a sense of smell they had, and all sorts of interesting things that might have affected their behavior.
This next story moves away a little bit from the scientific papers, and it's an interesting bit of history that we found in Atlas Obscura. So there's rumors that fake dinosaur bones, actually models made by the sculptor Benjamin Waterhouse Hawkins, who worked with Richard Owen in the 1850s, and he made the dinosaur models in the Crystal Palace in London. There's rumors that his models are buried under Central Park in New York City. You can read a lot about it on Wikipedia. There's even articles in the New York Times and in a children's book called The Dinosaurs of Waterhouse Hawkins by Barbara Curley. But anyway, Hawkins moved to America shortly after making the Crystal Palace dinosaurs, and he made dinosaur models in various cities. He got to New York in 1868 and told, quote, Edward Livingston Youmans, founder of Popular Science magazine, of his intention to reconstruct the American monsters in Central Park. This is according to Atlas Obscura. Andrew Green, the comptroller of Central Park, eventually assigned Hawkins to make models for a Paleozoic museum, which was supposed to be similar to the Crystal Palace. But there were a lot of delays. Hawkins made some models of Hadrosaurus and Laelaps, now Dryptosaurus, but then he was assigned to other work, and in 1870, Boss Tweed took over the administration for all parks in New York City and fired Hawkins to cut costs. Hawkins was disappointed, and he said so at a meeting in 1871, and that unfortunately prompted vandals to break into his workspace and smash his work with sledgehammers, as well as destroy all his molds and sketch models. And they told him to, quote, not bother himself about dead animals when there were so many living ones to care for. The remains of his work were buried in a place called Mount St. Vincent, which used to be a convent and is now where Central Park composts. This has led to the rumors, though there's many who doubt that there's actually anything to find. Some early articles in the New York Times reported that Hawkins' fragments were dug up shortly after being buried. Supposedly Hawkins himself dug up a couple of his own fragments, and that must have been a pretty terrible feeling to see them all broken and everything. But in a sense, the rumors may have some merit. The dinosaurs may still technically be in the park, since, according to the article, quote, there is evidence that the fragments were crushed and used to pave paths in the park. So something to keep in mind if you're ever walking around Central Park.
Next up is an article published in the journal Nature Communications titled Isotopic Ordering in Eggshells Reflects Body Temperatures and Suggests Differing Thermophysiology in Two Cretaceous Dinosaurs. It was written by Robert Eagle and others, but it's behind a paywall. Luckily, one of our favorite dinosaur journalists, Shana Montanari, was also a co-author on the paper and wrote up a great summary, so I could get a little bit of information on what they did during their research. So we talked about dinosaur body temperatures in quite a bit of detail back in episode 27, including how scientifically animals aren't classified as warm or cold-blooded, but rather endotherms and ectotherms, as well as occasionally mesotherms, which is somewhere in between. So modern birds are standard endotherms, but we have discussed before that some believe dinosaurs may have been mesotherms, but not too many these days think that they were ectotherms like they did back in the day when we thought they were just big lizards. What the authors did for this research was take advantage of the chemistry of the dinosaur eggs, or dinosaur egg fossils to be specific. Both modern bird and dinosaur eggs are and were made from calcium carbonate, which can be digested with acid into carbon dioxide. And this isn't really anything new. If you're into chemistry like I am, you can put all sorts of things into acid and it'll bubble and, go away like you see in any good sci-fi movie. A lot of times what's coming off is carbon dioxide and some other gases. But what's new about this is that they're using the ratio of isotopes in the carbon and oxygen to indicate the temperature that the egg was when it was formed inside the dinosaur. So this analysis is called clumped isotope analysis. In this case, they developed their correlation by comparing many modern birds and reptiles with different body temperatures, and then they developed a little model of what kind of isotope ratio that carbon and oxygen would have based on the body temperature. So then they used their quote-unquote paleothermometer to compare two groups of dinosaurs, specifically oviraptorids from Mongolia and titanosaurids from Argentina. So they found that the titanosaurid had a temperature of about 100.5 degrees Fahrenheit or 38 degrees Celsius, which is similar to a modern endotherm, but the oviraptorid was about 95 Fahrenheit or 35 Celsius, which is a little bit cooler than what we would expect from an endotherm, but not as cool as an ectotherm, so it may have been a mesotherm. Robert Eagle said in his press release, quote, "This could mean that they produced some heat internally and elevated their body temperatures above that of the environment, but didn't maintain as high temperatures or as controlled temperatures as modern birds. If dinosaurs were at least endothermic to a degree, they had more capacity to run around searching for food than an alligator would." So it's a little bit of evidence that dinosaurs were probably quick, because the higher body temperature, the more energy you have available. And just another interesting kink. I think last time we talked about it, we said dinosaurs were most likely mesotherms, but now it looks like maybe some of them were endotherms and some of them were mesotherms, so still developing science there. And last of the journal articles we're going to talk about this week is another article published in the journal PLOS One titled Perinatal Specimens of Saurolophus angustirostrus of Dinosauria hadrosauridae from the Upper Cretaceous of Mongolia, written by Leonard de Waal and others. So in the Nemegt Formation in Mongolia is an area with the best name of any fossil deposit that I've seen. It's called Dragon's Tomb. The area is known to have many fossils of a giant hadrosaur called Saurolophus angustirostrus. Until now, only adults had been discovered, but this article talks about a few juveniles. There's a really interesting ethics statement at the beginning of it. I hadn't encountered one of these in any of the dinosaur articles that we've reviewed before, but apparently the fossil that they're describing in the paper was poached from the formation and then sold in Japan and then sold in Europe, and then it was located in a private collection by one of the authors who then donated it to the Royal Belgian Institute of Natural Sciences, and then they negotiated with the Ministry of Culture, Sports and Tourism of Mongolia, and then officially gave it back to the Institute of Paleontology and Geology of the Mongolian Academy of Sciences, which is where that Nemegt Formation is, and that's where it's currently housed. So when they published this article, they were studying it with permission from the museum that ultimately ended up with it back in Mongolia. So I guess it was smuggled and then sold a few times and then eventually given back to the rightful owner there. But that may have made it a little bit more difficult to see exactly where it came from, since when things are stolen, they're not necessarily documented real well. So the specimen is a solid piece of rock with several fossils in it. On one side of the rock, there is an articulated partial fossil, which includes a squished skull, part of a back, tail, ribs, and the right hind limb. The left side of the body is probably still buried in the rock, but they don't want to separate it since it looks so amazing the way it is. The other side of the rock, meaning the other side that we can still see, has 2 or possibly 3 more specimens, but the bones are all mixed up, so it's kind of hard to tell how many there are, and they're not articulated, so it's difficult to identify the bones too. They all appear to be either fossilized just before or after hatching, and they were actually fossilized along with eggshell fragments, evidence that they were very young and not just small examples of another species. Includes that their bones appear spongy at joints and their skulls were missing the crest that adults have, but they weren't completely fused at that point either, which would have left room for a crest to grow in the future, and then, of course, the eggshell pieces. If you're wondering how big these dinosaurs were, their skull was about 1/20th the size of an adult, but we've mentioned before that skulls tend to be proportionally a little bit bigger than the rest of the body when an animal is born, so it was smaller than 5% of the size of an adult, so little tiny guys. And evidence shows that they were probably near a riverbank, which would have helped them fossilize as a river shifted and then laid sediment on the specimen shortly after, and that's how you get such a good preservation like they did. Finding specimens like this always helps to understand how dinosaurs developed, and in this case it's especially true since it shows that the crest was developed later in life rather than the dinosaur being born with it.
And we'll wrap up our news with a couple of entertainment items. First, we found out about a relatively new YouTube channel called the Prehistoric Channel. And this channel is made by a kid who posts videos and he shows dinosaurs in action as well as reviews of dinosaur models. He has at least 38,000 subscribers. Apparently, he only had 22 subscribers until someone posted about his channel on Reddit. The videos are pretty entertaining, so if you have a chance, you should check it out. Also, thanks to Tori via Twitter for telling us about this one. There's a new dinosaur game coming out soon called Robinson the Journey. And there's a stunning video trailer which shows a number of incredibly realistic dinosaurs. We'll be sure to post it on our blog. Here's the official description of the game according to their website. Go beyond boundaries in Robinson the Journey, a brand new virtual reality game from Crytek. Harnessing the power of CryEngine, Robinson the Journey will offer players an unparalleled sense of presence in a game world as they assume the role of a young boy who has crash-landed on a mysterious planet. With freedom to explore their surroundings in 360 degrees of detail, players will become pioneers by interacting with the rich ecosystem around them and unearthing incredible secrets at every turn. So, yes, the video trailer lives up to this epic-sounding description, and we look forward to checking out this game whenever it comes out. So that wraps up the news. Now on to the dinosaur of the day, Muttaburrasaurus. Muttaburrasaurus lived in northeastern Australia in the early Cretaceous, and its name means Muttaburra lizard. It's named after Muttaburra, the site in Queensland, Australia, where it was found, and it was described in 1963 from a partial skeleton that included the skull, lower jaws, parts of the pelvis, part of the front and hind limbs. The bones were actually collected by Alan Bartholomai and Edward Dahms, and the species was named in 1981 by Bartholomai and Ralph Molnar in honor of Doug Langdon. The type species is Muttaburrasurus langdoni. Its name means Muttaburra lizard, and the skeleton found in Muttaburra was about 60% complete. Most likely its carcass floated out to sea from nearby land and then sank and fossilized. Doug Langdon said he found the bones in a dry creek bed, and he actually wrote past them. And he said, quote, "I was mustering cattle, and it was a dry season, so there wasn't much grass around, and I happened to ride down to this waterhole to have a look for any cattle, and there's none there, so I rode on, and I rode right past the bones." So again, the first fossils were found on his property in 1963, but it took some time to collect the bones, and his sheep and cattle accidentally wore some of the bones down. Also, some of the bones on his property were taken by locals as souvenirs, though many returned them when local authorities set up an amnesty for missing pieces. Muttaburrasaurus teeth have been found at other sites, one of them lightning ridged, they're actually opalized teeth, and other skulls have also since been found. In the two Muttaburrasaurus skulls, they have slightly different crests. One, known as the Dunluce skull, and was the second skull to be found, has a shorter nasal crest, and it's slightly older than the first skull found, so that may mean that the crest just changed over time. Skulls may also be different for males and females, or maybe potentially it's even a different species. There's possibly 2 to 3 species of Muttaburrasaurus, but only one so far has been formally described. These fossils were found in rocks that formed a marine environment, which means that shallow seas covered a lot of eastern Australia during its time. Muttaburrasaurus may have been a good swimmer. This is based on trackways in the Australia's Dinosaur Stampede National Monument. 3,000 footprints were thought to be from dinosaurs stampeding to get away from a predator, which had large 3-toed footprints, but now paleontologist Anthony Romilio said those prints were of a wading Muttaburrasaurus-like herbivore, and the other prints were from dinosaurs swimming in a prehistoric river. Muttaburrasaurus was 26 feet or 8 meters long and weighed 3.1 short tons, 2.8 metric tons. There's debate whether or not it was quadrupedal, but now most think it was bipedal. Originally, scientists thought that it had a thumb spike, but the foot was long and broad with 4 toes, so it probably didn't. It had weight-bearing hooves. It could probably run away from its predators, and even though many think it was bipedal, it may have also spent a lot of time on all fours. It looked kind of like an iguanodon with a long, stiff tail, and it had short forelimbs and a flat, wide skull. Also, the skull had a hollow chamber, an enlarged nasal cavity, and a pointed snout. This was possibly used for display or to make distinctive calls, but no fossilized nasal tissue has been found, so it's unclear what it was for. It also had powerful jaws and teeth that could shear, but the way the teeth were arranged meant it couldn't actually chew. Some scientists used to think it ate meat, but now they just think it was shearing teeth. In 1981, Molnar thought that Muttaburrasaurus was an omnivore, but then in 1995 changed his opinion to herbivore, again with the shearing teeth. Muttaburrasaurus did have strong jaw muscles in the rear part of the skull, where the muscles are attached. It's actually deeper compared to other ornithopods. Instead of continually replacing teeth, Muttaburrasaurus probably replaced all of its teeth at once. It had a tooth row that formed a shearing surface instead of a grinding one, again, shearing. It also had a beak, so it probably could eat some tough vegetation, like cycads. Again, it was an ornithopod, or duck-billed dinosaur, but its teeth were more like Triceratops. Originally, Muttaburrasaurus was classified as Iguanodontidae, then later as Camptosauridae, Drysauridae, or Hypsilophodontidae. Now it's considered to be part of Rhabdodontidae. Molnar assigned it to Iguanodontidae, but then in 2010, Andrew McDonald released a study that placed it in Rhabdodontidae. It lived in conifer forests near the edge of the inland Eromanga Sea, and in Lightning Ridge there would have been extra long days in the summer and extra short days in the winter. Muttaburrasaurus may have seen sauropods, such as Diamantinosaurus and Ostrosaurus, also the ornithopod Atlascopcosaurus, and pterosaurs, like Osidrigo. Muttaburrasaurus is one of the most complete dinosaur skeletons in Australia, after Minmi and Ankylosaur, and it was the first to be cast and mounted for display. There's actually fewer than 20 recognized species of dinosaurs in Australia so far. You can see Muttaburrasaurus' skeleton/cast at the Queensland Museum, Finders Discovery Centre, and National Dinosaur Museum. All of these are in Australia. The company Kellogg sponsored the cleaning up and putting on display of Muttaburrasaurus in the museum, and Muttaburrasaurus will be one of the 10 dinosaurs in QUT's The Cube, which we've talked about in a few episodes of this podcast, and that'll be on display in December of this year. You can see Mutt, the nickname for Muttaburrasaurus, a full-size fiberglass statue near Main Street on Uhendon. There's also a Muttaburrasaurus playground called Mimi, where kids can climb through its belly and slide down her tail, and Mimi is also in a children's book. Muttaburrasaurus appeared in a local community calendar that was meant to raise money for a school and an ambulance defibrillator. People posed naked with props, and one elderly couple posed naked with a life-size Muttaburrasaurus replica. You can also see Muttaburrasaurus in an episode of Walking with Dinosaurs, and the dinosaur appears in Land Before Time 3 as a character named Mutt and his father, as well as in the Land Before Time TV show. Muttaburrasaurus is also in the 1995 film Muttaburrasaurus: Life in Gondwana, which is a short 30-minute film about a young Muttaburrasaurus that becomes separated from its mother. In April of this year, the town Muttaburra honored Doug Langdon, who passed away last November at age 82 from cancer, with a special horse race, the Doug Langdon Memorial Race, and the race committee and jockeys paid him tribute by wearing black armbands. Muttaburrasaurus may become one of Australia's state fossils in Queensland. So far, only 2 of Australia's states have fossils: New South Wales, this was officiated by the Geological Survey of New South Wales, and Western Australia, and theirs was picked based on public submissions. The idea of having state fossils came from the US. The first states with fossil emblems were Louisiana, their fossil is petrified palm wood, then Maine, which has prehistoric plant Perdica quadrifaria, and Georgia, which has a shark tooth, back in 1976, and this was because it was all good for tourism. Australia's first state fossil was announced in 1995. Western Australia has a fish fossil. This was selected by a democratic process. Actually, teachers from a primary school in Perth heard about the U.S. state fossils and lobbied their state government to have a state fossil as an exercise for their students. The government made a public call for the fossils to consider, and the fish won based on a petition signed by nearly 1,000 people and supporting letters from international paleontologists. But going back to Muttaburrasaurus, in 2013, the Queensland Museum published a children's book, Happy Birthday Muttaburrasaurus, to celebrate 50 years since the first bones from the dinosaur were discovered. So back to Muttaburrasaurus' family, rhabdodontids. They were herbivores and ornithopods that lived in the Cretaceous, and they had deep skulls and jaws. Fossils have been found in Europe and Australia. This family didn't appear until 2002 when David Weschempel and colleagues proposed the family. And depending on who you ask, Muttaburrasaurus is part of this family. The original definition would not have included Muttaburrasaurus, but Paul Serrano's definition that it's the most inclusive clade, which contains Rhabdodon priscus, but not Parasaurolophus walkeri, would include Muttaburrasaurus.
And our fun fact of the day goes back to Sabrina's comments about how Muttaburrasaurus and Triceratops had both a beak and teeth. And some ornithischian dinosaurs evolved to have those large beaks. And then because their beaks could help chop up their food, or at least tear it off branches and things, they didn't need front teeth anymore, and eventually these groups lost their front teeth entirely.
And that wraps up this episode of I Know Dino. Again, if you would like to support our podcast, please visit our Patreon page at patreon.com/iknowdino, and Patreon is Patreon. Thanks for listening, and until next time.
Thank you for listening to I Know Dino. If you have any questions or comments about dinosaurs, we'd like to hear from you at plesiosaur at iknowdino.com. And for more information on dinosaurs, go to iknowdino.com or follow us on Google, Facebook, Tumblr, or Twitter at I Know Dino.